Welcome to The Explainer. Today we're talking about something, well, pretty wild. A new theory that could completely flip our understanding of the human mind on its head. It suggests our thoughts aren't just abstract signals, but that they have actual, physical, geometric shapes.
So let's get right into it. You know how we always talk about the brain like it's a computer, like it's all just circuits and data? Well, what if that's totally the wrong metaphor? What if every single experience, every new skill you learn, literally warps the very landscape of your consciousness?
So, to really wrap our heads around this idea, we've got to first look at a concept scientists are already using to map out the brain's activity. It's called a neural manifold.
This is a huge shift in thinking, right? Forget about just one neuron firing off. Instead, picture a thought. Let's say the concept of a dog as a specific place on this crazy multidimensional map inside your head. And things that are conceptually close, like puppy or wolf, they're right there nearby on the map. It creates this whole mental terrain.
Okay, so if our mind is this landscape, what's doing the carving? What's creating the mountains and valleys of everything we know? Well, this new, pretty bold hypothesis says it can all be boiled down to a single, really elegant equation.
And here it is. This is called the cognitive metric tensor. Now, I know it looks a little intimidating, but the idea behind it is actually super simple and really profound. It's basically saying that our experiences don't just add information, they physically reshape the geometry of how we think. Let's actually break that down. Think about it like this. You start with a kind of default landscape for your mind, a base geometry. That's the delta part. But then you add this other term, the E, which stands for experience. And this experience tensor, that's the big leap of faith in this theory. It's saying that every single thing you do, see, or learn literally warps that mental space, changing how far apart ideas are from each other.
Okay, now it is super important to be clear about something here. The source material is really upfront that this is not a proven fact. Not yet, anyway. Think of it as a research program. It's a powerful and, really importantly, a testable idea. It gives scientists a real mathematical model they can take into the lab and try to prove or disprove.
Okay, so how on earth would you even begin to test a theory like this? The idea that learning literally reshapes your mind's geometry? Well, the folks behind this framework have an answer. They've proposed a whole new kind of programming language just for this.
They're calling it Geometric Configuration Language, or GCL for short. And you shouldn't think of it like a normal programming language, like Python or Java. It's more like a specialized toolkit for mapping out this mental terrain. And, this is the really cool part, for actually planning routes across it. And here's where you can see just how practical this could be. Using GCL, a scientist could, say, define a cognitive space, that's the manifold, and set all its starting properties. But then, and this is the key, they could define exactly how much a new experience will warp its shape. It's like setting the rules for how the mind's landscape evolves.
And this right here, this shows the end game. Learning something new, let's say, learning to play the piano, gets totally reframed. It becomes a geometry problem. You're just trying to find the shortest, most efficient path, that's what a geodesic is, between the spot on your mental map that represents novice piano player and the spot that represents expert. How cool is that?
But wait a second. For this whole landscape to change, for these new paths to get carved out, something has to be driving it all, right? There's got to be some kind of rhythm, like a master clock that tells the mind's geometry. Okay, time to update based on what just happened.
And the theory points to this number, 0.0159 hertz. That is an incredibly slow frequency. We're talking about one cycle every 63 seconds. And the researchers are proposing that this super slow oscillation could be the fundamental rhythm that orchestrates not just how we learn, but consciousness itself.
So the big prediction here is that this super slow frequency is the master clock, the thing that updates our mental map. But it might be even bigger than that. They think it could be the signature of the brain hitting a critical point. Like a phase transition, the way water freezes into ice? It's the moment unconscious processing might just tip over into what we call subjective conscious experience. And the best part? It's a direct, testable prediction.
Okay, so what does all this actually mean? What are the real-world implications here? Well, if this whole geometric framework turns out to be right, its supporters are claiming it could lead to some absolutely massive breakthroughs, solving some of the deepest mysteries we have in science. And we're not talking about one or two little discoveries here. The theory lays out a roadmap to solving 7
7 of the hardest problems that scientists and philosophers have been banging their heads against for centuries, and it all stems from that one core idea about the geometry of the mind.
First up, the two biggest elephants in the room when it comes to consciousness. It claims to solve the hard problem, which is basically the question of why we have feelings and subjective experiences at all. Why does red look red? The theory says that experience, that qualia, is a geometric phase change. And then there's the binding problem. How does your brain take in all the sights and sounds and smells and stitch them together into one seamless reality? Well, that ultra-slow frequency we talked about, that's the proposed master clock that syncs it all up.
And believe it or not, the claims get even bolder from there. The theory suggests we've basically achieved the ability to decode the brain's own programming language with GCL. And maybe the most mind-blowing claim of all, that we now have an actual engineering blueprint to build truly conscious AI. We could program machines to have the same geometric phase transitions that, in theory, create our own consciousness. And the implications just keep expanding into medicine, into education. Things like depression or schizophrenia could be seen and maybe even treated as geometric problems. Literally, issues with the shape of a person's mental landscape. And imagine if learning could be perfectly optimized, because we could mathematically calculate the absolute most efficient path to mastering any skill. And finally, the 7th claim, that this framework establishes nothing less than a unified physics of the mind. The goal is to build a solid mathematical bridge that connects everything, from the tiniest quantum stuff happening inside our neurons, all the way up to the grand, unified geometry of our conscious experience.
But you know, when you step back, the single biggest breakthrough isn't solving any one of these huge problems. It's the complete paradigm shift that this represents. It changes the entire question. We stop asking, how does a physical brain create a non-physical mind? And we start asking, how does the geometry of this physical system become the experience itself?
So yeah, this framework it's bold, it's testable, and it's a profoundly new way to think about thinking. It's not just a theory on paper, parts of it are already being simulated. And it leaves us with this final, really fascinating question. If our thoughts really do have shape, are we on the verge of finally drawing a complete map of the human soul?